Okay, let's go live and share this with some people. Share it on Twitter, we share it on Discord, and on this Discord, let me see, this one, and let's also share this on Telegram. Boom. Okay, that's that. Okay, Advent of Code. I'm by myself today. I really liked yesterday's having somebody else here to do it with me. But yeah, let's try our hand solo today. Sunco Suffer, hello! Thanks for joining me. I'm just about to read day 11 of Advent of Code and give it a shot. That's the link, in case you were wondering. Have you done Advent of Code yourself? Meanwhile, I'm going to go start read the problem description. Day 11, Dumb Octopus. You enter a large cavern full of rare bioluminescent dumb octopuses. At least they're pretty, right? They seem to not like the Christmas lights on your submarine, so you turn them off for now. There are 100 octopuses around, arranged neatly at a 10 by 10 grid. Each octopus slowly gains energy over time and flashes brightly for a moment when its energy is full. Although your lights are off, maybe you could navigate through the cave without disturbing the octopuses if you could predict when the flashes of light will happen. I'm struggling with today's puzzle. Oh, that doesn't bode well for me. Let's see how I fare. Let's see, each octopus has an energy level. Your submarine can remotely measure the energy level of each octopus, your puzzle input. For example, and then we have a 10 by 10 grid of numbers, okay. The energy level of each octopus is a value between 0 and 9. Here, the top left octopus has an energy level of 5 and the bottom right of 6 and so on. You can model the energy levels and flashes of light in steps. During a single step, the following occurs. Okay, so these are the rules that we will have to program in a bit. First, the energy level of each octopus increases by 1. Then, any octopus with an energy level greater than 9 flashes. Okay, so any 9 that is, when you reach a 9, it will go up and then flashes. This increases the energy level of all adjacent octopuses by 1. Including octopuses that are diagonally adjacent. Okay. If this causes an octopus to have an energy level greater than 9, it also flashes. This process continues as long as new octopuses keep having their energy level increase beyond 9. An octopus can only flash at most once per step. Okay. Finally, any octopus that flashed during this step has its energy level set to 0 as it used all of its energy to flash. Okay. So, okay. So in this case, here's a tricky part already, right? So let's say something goes from 9 to then flash. The end result at the end of the run, whatever happens, it will always be that that one becomes 0. So any index that flashes at that point can never flash again in that same step, and it will end up with 0, even if it, like other flashes beside it, set it off, right? Let's see, adjacent flashes can cause an octopus to flash on a step even if it begins that step with very little energy, considering the middle octopus with 1 energy in the situation. Yeah. Okay. An octopus is highlighted when it flashes during the given step. Let's see, here is how the larger example above progresses. Before any step, after step 1, after step 2. Okay, so here's an example. After step 10, there have been a total of 204 flashes. Fast forwarding, here is the same configuration every 10 steps. Okay, so this is like the test case that you can use to test your logic. After 100 steps, there have been a total of 16 156 flashes. Giving the starting energy levels of the dumb octopuses in your cave. Simulate 100 steps. How many total flashes are there after 100 steps? Okay, yes, I try to do the advent of code every year. Ah, okay, that's cool. I started 2 years ago, so in 2019. I had a lot of fun with that. That was the year with the encode stuff. Okay. Okay, so let's see what we can do for this. Okay, so we'll have a 10 by 10 grid, and I think we'll just start with the test input here in this case. Because this will be tricky, so let's just start there right away. So var lines, actually we can do dot 2 lines, no, 2 lines. And then we can select x dot to array. Okay, so we have var map is this. So this will be a list of int, so that is fine. I think we should keep track of the indices that flashed. Hash set int y int x flashed. Let me see. We can do neighbors as well. Let's do it in the same order here. Neighbors. So we have, actually we do -1, -1. We have -1, 0. We have -1, 1. And the middle row will just be -1, let's see, now this will be 0, 0. So these are all the 9 surrounding spots as offsets. And probably with stuff like this, there's probably like a pattern that you can see happening, that you can predict, or that you can calculate the end step in one go with a certain algorithm. But yeah, I don't know that one, so we'll just code it and see if we ran into troubles later on. So const int sim steps is 100. Probably need to spit out the intermediate ones as well. Let's see. For int step is 0, step smaller than sim steps plus I. We do flash.clear. Let's see, and then we go, we just go through each of them. For int, okay, we can also do const int rows is, let's see, map.length, count, const int why is it complaining here? Ah, okay, sure, static read only. Okay, let's just do int calls is map 0.count. So now we have the rows and calls. We do int last row is rows -1 because we need to keep checking bounds. Int last call is calls -1. Actually, we can, yeah, this will be enough. So now we do, why is it complaining here? Tuple name is not being unique. Ah, good morning. X. Okay. So now we can walk through each of them and then see that effect. We also need to have, like, whenever it increases or it flashes, we need to walk all the steps as well. Okay, so let's see. The first step was it increases each by 1. Okay. So let's do that. Step 4 int y is 0, y smaller than rows increase y. Let's see, we do x here. Same for calls. We increase x. Let's see. Now we do, we increase the value. Let's see. If map y x, and we increase this one. Flash. So we do flash.add, no, add y, comma x. Sure. And now we need to walk all of the neighbors. So we do for each var offset in neighbors. Let's keep a variable for those as well. So we do target x. Is x plus offset.x. Target y is y dot offset y. If target x larger than larger or equal to 0 and target x smaller or equal to last row. I could have done actually the row count here as well, but this is fine. Target y larger or equal to 0 and target y last call, and I need to swap these actually because x tests the call and y targets the row. So if this is within range, we can increment it. We can do if we do the same actually. So let's make this a function. So let's do action and we go int y, int x. This is the parameter int type. Increment is pos. Okay, so we just define it like here. And we do pos.xy and flashed contains pos. Pos. So we do it like this. And then we call ourselves increment target y, target x, right? Can't I call myself? Oh wow. Is that better? Jesus. I wonder if this actually could cause an issue here. But we'll find out soon enough. So yeah, we have it like that. So we can do, instead of this, we can just do increment and we do y comma x, right? So this takes care of everything. And now we do if flashed count. Is this a length? No, count larger than 0 for each var pos in flashed map pos.y pos.x equals 0. So we reset all of them. Okay. We also need to keep track of how many times we flash. So we have int flash count is 0. We increment this one, and that is fine. So yeah, that should already be part 1. 16.5. Okay, let's see if we can get this result here. Code runtime, sweet. Let's also write out the answer. Console, but right line. Part 1. Okay, let's see, part 1, and this will be flash count. Let's run this again. 16.5, okay, so we already have it. First try, that is pretty dope. I like that a lot. So let's hope part 2 isn't too crazy. But yeah, this gives me good hope. Oh, come on. So let's run this. And now I did something stupid here. No, let's see. I called it map. Let's keep the naming consistent. Oh, it's not that different from the input. So let's see. Right answer. Woohoo! And now on to part 2. It seems like the individual flashes aren't bright enough to navigate. However, you might have a better option. The flashes seem to be synchronizing. In the example above, the first time all octopuses flash simultaneously is step 195. Okay. If you can calculate the exact moment when the octopuses will all flash simultaneously, you should be able to navigate through the cavern. What is the first step during which all octopuses flash? Oh wow. This will be some crazy number, right? And this will probably be the big issue where I will have to think of something smart to do. Okay. So let's do this. We have, okay, we can do that here. Int map size is rows times cols. And part 2 will actually be, let me just copy paste this and I'll see if I change that later, but for now I'll just do it again. Let's stay with the test input. Yeah, can we do that? I need to stop running. Okay, so instead of going 100 loops, we'll just go on forever. And we'll do while flashed count not equals, oh, where is my code? Not equals map size. And I need to keep track of the step, right? Int step count is 0. And we do, come on. Let's see. Okay, so this should spit out 195 now. Okay, so that is correct. But something tells me that this one won't be as fast and it will be some crazy number, right? No. Okay. Okay, why was this so easy? Huh, okay. I thought this would be a lot harder than it is. Okay, got away with another one. Okay. I really thought that this would be like some insane, difficult thing to brute force, that you have to like be able to detect an underlying thing so that you could like skip ahead a few billion iterations or something. But okay, because usually with these type of you make it look so easy. Ah, thank you. But it's, yeah, in this case it's not that hard, because for part 2 what they ask you to do is just go on until it's, let me scroll to the bottom, scroll on until it's fully flashed. So, and since we already keep track of how many times it flashed in the current round, and you can only flash each position once, it's just asking you, okay, keep looping until everything on the map has flashed. So yeah. So do you want to share where you are at? Maybe I can see the approach that you're taking and see if we can help you. Or did this give you another idea to on how to fix your version? I actually went back and did a few of 2015 ones yesterday evening. Like this one, this was such a pain in the ass just even to fill in all the inputs, right? Have you gone back to 2015 and did those as well? I've been trying to do them whenever I have a bit of time. But yeah, these are both like branching code, and this gives me a whole different approach. Ah, okay, that's cool. Well, then I wish you good luck on that. And yeah, maybe join me again tomorrow and see if I can keep up this streak. Because I think today and yesterday was fairly easy. Yesterday with the stack parser, it was also like sub 30 minutes to do the 2 parts. So yeah, curious to see what tomorrow holds. So thank you for keeping me company while streaming. It's always nice to have somebody in chat. And I wish you very good luck with today's challenge, and hope that you finish, and maybe see you tomorrow. Okay, so thank you, and see you tomorrow maybe. Bye bye.